because longer bonds are weaker bonds. In presence of base SN2 reaction, it is more important. Finkelstein reaction, it is allylic position, benzylic, vinylic. 2017 online question. Can you remember Finkelstein, Swarts, Wurtz and all preparation methods in just one class? By the end of this video, you will never confuse them again. Hello students, let us start. Alkyl halides preparation and properties. Alkyl halides are halogen derivatives of alkane. There are 4 types: monohalides, dihalides, trihalides, tetrahalides. Respect to general formulas given, examples, associated examples given here. Remember, when all hydrogens of alkane are replaced by halogen atoms, then compounds are known as per-halo compounds. Example CCl4, per-halomethane. Monohalides, primary alkyl halide, secondary alkyl halide, tertiary alkyl halide. Primary alkyl halide is where halogen attached to primary carbon, halogen attached to secondary carbon, halogen attached to tertiary carbon. Important sequence of alkyl halides. Reactivity follows this sequence. Longer bonds are weaker bonds, easy to break. Easy to break, readily reaction occurs. Bond energy sequence exactly opposite. Bond energy inversely proportional to bond strength. Reason, shorter bonds are stronger and difficult to break. Difficult to break, difficult to react. Boiling point, Ri greater than remaining 3 alkyl halides. As the size of halogen increases, van der Waals force increases, boiling point increases. Boiling point sequence here, molar mass increases, boiling point increases when same compounds with different number of halogen atoms like chlorine 2, 3, 4, then you can use molar mass directly proportional to boiling point. Different alkyl halides, then you can use size of halogen increases, van der Waals force increases, boiling point increases. Ci, Cbr, Cf, CCl, dipole moment value, that is CCl highest. Reason why fluorine is less than chlorine, due to smaller bond length of Cf, dipole moment of Cf is less than CCl, because dipole moment charge into bond length. Bond length is very less, just it is second place after CCl. Methods of preparation of alkyl halides. From alcohols, HX. Alcohol reacting with HX, it forms alkyl halide. Remember, secondary tertiary alcohols will show SN1. Primary alcohol preferred with SN2. See, SN1 SN2 dedicated video before this previous video based on SN1 SN2. Properly go through SN1 SN2. Separately I made video based on SN1 SN2 because it is a high weightage topic. From phosphorus halides, PCl5, PCl3, both are chlorinating agents. So it gives alkyl halide with respective products. Here no arrangement in PCl5, PCl3 reactions. By reaction with thionyl chloride, Darjan's procedure, ROH with SOCl2 pyridine combination. Here there is base. In presence of base SN2 reaction, in absence of base SN9, meaning intramolecular nucleophilic substitution. Within the reaction, nucleophile attacks. RCl, SO2, HCl, RCl, SO2, products are same. Retention of configuration observed, here inversion of configuration observed. In the absence of base SNI reaction, in the presence of base SN2 reaction. For more in detail SN1, SN2, refer previous video. For example, if reactant given SOCl2 in the absence of base, SOCl2 in the presence of base. See here, towards the viewer OH, after the nucleophilic substitution Cl, same towards the viewer. Retention of configuration, no change in configuration. But here towards the viewer group became away from the viewer, so there is inversion of configuration here. Borodine-Hunsaker's reaction, RCOOAg, silver salt of carboxylic acid react with X2Cl2Br2, CCl4 on heating gives RxCO2AgX. Halogen exchange reaction, Finkelstein reaction, it is more important. Finkelstein reaction of alkyl iodide, alkyl halide, XCl bromine, in presence of NaI-DMSO, alkyl iodide is prepared. So it is important method to prepare alkyl iodide, prepared by using Finkelstein reaction. Swarts reaction, you can mention Swarts reaction even like Swarts reaction. So Swarts reaction here, in this case, reaction occurs alkyl halide to form RF. It is method to prepare alkyl fluoride. Above method is alkyl iodide. So it is best method to prepare alkyl fluoride by using alkyl halide. Inorganic fluorides we use here. Inorganic fluorides AgF, SbF3, Hg2F2, COF3, etc. So alkyl fluoride is prepared by using this Swarts reaction. By reaction of alkanes with sulfuryl chloride SO2Cl2, sulfuryl chloride in presence of peroxide, RCl, HCl, SO2 formed. Reaction with ROH, red phosphorus H2, X is bromine or iodine. Red phosphorus H2 forms PX3. Upon reaction, it will form RX. By using alkenes, so like H2CCl4, these are hydrocarbon 11th class reactions. H2CCl4, Markovnikov's rule occurs. So here H2 forms X plus X minus. Markovnikov's rule we know. Positively charged ion attaches to double bonded carbon with more number of hydrogens. Anti-addition occurs, that's why opposite side. Groups are added from opposite sides. H2H2O, here reacting species X plus and OH minus. Again Markovnikov's rule, X plus added to the double bonded carbon with more number of hydrogens, OH minus to other carbon. Anti-addition occurs here also, OHX opposite side. HBr H2O2. HBr in presence of peroxide gives anti-Markovnikov's rule, where H plus added to the opposite carbon, where carbon with less number of hydrogens, bromine to double bonded carbon with more number of hydrogens. Allylic substitution, benzylic substitution. So here you will get N-bromosuccinimide, bromine H nu light, N-chlorosuccinimide, chlorine 500 degrees Celsius, chlorine H nu, tertiary butoxy chloride. All these reagents adds bromine or chlorine at allylic or benzylic position. It is allylic position, benzylic, vinylic. For example, see, it is allylic carbon. It is allylic carbon here, this one. So here NBS, N-bromosuccinimide, add bromine to allylic carbon. Direct reaction. You have to remember the reagents. Br2H nu, benzylic carbon it adds. Br2H nu, allylic carbon, bromine added. Br2CCl4, addition of bromine occurs. Anti-addition, bromine occurs. Chemical properties of alkyl halides. Nucleophilic substitution reactions, SN1 SN2, very important high weightage topic. Already mentioned to you, dedicated video on this particular topic made previous video. Before watching this video, watch previous video, SN1 SN2, high weightage in this chapter. Next, Wurtz reaction, where alkyl halides, if it is identical along with sodium triether, alkane produced along with NaX. If non-identical alkyl halide, two alkyl halides taken, then mixture of alkanes you will get RR, RR, R dash, NaX, all combinations. Halogenation of alkyl halides, alkyl halide chlorine in presence of heating or UV light, one hydrogen replaced by one chlorine every time, so CH2Cl2, CHCl3 again CCl4 by the elimination of HCl in each step. Reduction or reducing agents, alkyl halide reduction that is hydrogen added, RH and HX. Like see here HI, red phosphorus, hydrogen added, you will get C2H6 plus I2. Formation of organometallic compound OGM, RX magnesium triether, it forms RMGX, Grignard reagent. Like C2H5Br, zinc triether, C2H5 twice, zinc, dialkyl, zinc bromide. C2HCl, sodium Pb alloy we are using. So here it will form tetraethyl lead, which is anti-knocking agent, which is used to reduce sound in engine of automobiles. Tetraethyl lead. So here see note, what is organometallic compound? Organometallic compound is compound in which metal carbon bond is present. So here see metal carbon bond is, that's why it is organometallic compound, which is specially known as Grignard reagent, GR. Friedel-Crafts reaction, alkylation, where alkyl group is added to the benzene group, that is benzene, alkyl group, alkylation, CH3HCl. Okay. Dihalides we know, Zem dihalides, vicinal dihalides, alpha omega dihalides. Zem dihalides, vicinal dihalides, alpha omega dihalides. Meanwhile, once you remember here, so this reaction will not occur, you write here, will not occur when with CH2 double bond CHCl, because it will form unstable carbocation, and if any strong ERG, electron releasing groups, or EWG, on benzene ring. Because if any ERG, it will react with AlCl3, Lewis acid. If any strong EWG, electron withdrawing group, it deactivates ring, so that no further alkylation occurs. So remember, dihalides, gem dihalides, vicinal dihalides, alpha omega dihalides, same carbon contains two identical halogens, geminal, two identical halogens, vicinal, halogens replaced by three or more carbons, halogens separated by three or more carbons, alpha omega dihalides. Adjacent carbons vicinal, same carbon geminal. Methods of preparation of dihalides. Dihalides you see here, carbonyl compound PCl5, gem dihalide, alkyne HBr, first HBr added, and again one more HBr, geminal dihalide. Vicinal dihalide, alkene Br2, vicinal dihalide addition occurs. PCl5, OH replaced by Cl, vicinal dihalide. Alpha omega, cyclopropane Cl2, ring open alpha omega dihalide. Minimum 3 carbons between halogens. Chemical properties of dihalides. Vicinal dihalide or gem dihalide. Alcoholic KOH, which is dehydrohalogenating agent. It removes HX and forms. So it is removing HX and forming. What it is forming? It is forming alkyne. If it is aqueous KOH, Cl substituted by OH and will form compound like this. Aqueous KOH, vicinal dihalide, it is geminal dihalide. So what you will get? Same carbon having two OH groups, because in place of halogen we are adding OH. Remember, alcoholic KOH removes HX, aqueous KOH replace Cl by OH, it gives OH. Same carbon having two OH unstable, so removal of water molecule, finally you get aldehyde. Vicinal dihalide with KCN, Cl substituted by CnCN, and hydrolysis gives COOH. We know cyanide and hydrolysis gives COOH. Adjacent carbons having COOH eliminate water molecule to get stability, which is succinic anhydride, which is succinic acid. Geminal dihalide, KCN, same process, cyanide, carboxylic acid. Same carbon having COOH, we have to eliminate CO2, decarboxylation, remaining is monocarboxylic acid. Adjacent carbons having COOH, eliminate water molecule. Same carbon having COOH, eliminate CO2. Vicinal dihalide, zinc alcohol, which is dehalogenating agent. You specify here, dehalogenating agent, which removes halogen and forms same carbon product. No change in number of carbon atoms. Geminal dihalide, zinc and methanol on heating, twice the carbons of reactant. Reactant having 4 carbons, 3 carbons, you will get 6 carbons. Meaning such 2 units merge to form product here. You have to remember. Alpha omega dihalide, zinc reacting with alpha omega dihalide and forms one ring and forming zinc bromide. Removing halogens and ring formation is observed. And see JEE Main 2017 online question. Observe the question. Which of the following compounds will not undergo Friedel-Crafts reaction with benzene? Remember, vinyl carbocation highly unstable, it will form unstable carbocation. So it is forming unstable carbocation. Already we wrote above. If benzene ring having strong ERG, here you see. If benzene ring having strong ERG, here you can see strong ERG, electron releasing group or electron withdrawing group, or vinyl halide, reaction will not occur. Vinyl halide will form unstable carbocation. So here reaction will not occur with respect to vinyl halide. Direct question it is. The major product of the following reaction is, see what is the role of KOH here? KOH is dehydrohalogenating agent, which removes hydrogen halogen. So now if you are removing hydrogen halogen here, what happens? Observe it. Okay, see here what happens. So it removes hydrogen halogen, we know. So what we do here now, we have to remove hydrogen halogen from this given substance. How? Let us see. For example, if you remove this halogen from one carbon, hydrogen from other carbon. If you remove this hydrogen overall, so you will get here double bond here one side, where here double bond plus one more here. If you remove this bromine, hydrogen from this, so you will get here one more double bond here. So overall if you see, two double bonds in conjugation, that is more stable. Even it is more stable, with respect even after the product, two double bonds in conjugation, that is more stable, resonance. So removal of hydrogen halogen, here also hydrogen halogen will give double bond here, double bond here. After the removal of hydrogen halogen, 2 moles. So finally form double bonds in conjugation even with respect to benzene ring, phenyl ring also. Overall it is extended conjugation, important. Okay. I hope all the questions clear to everyone. SN1 SN2, refer previous video, dedicated video given for SN1 SN2 with important tricks. Don't miss that video. Please watch previous video, then come to this video. Thank you everyone.